Hey everyone, welcome to The Explainer. So today we are tackling a pretty massive milestone. We're going to completely demystify one of the most notoriously difficult, head-scratching parts of the AP Computer Science Principles exam, and that is data abstraction for the Create Performance task. I know, this topic can feel kind of abstract. Yep, pun totally intended. But by visually breaking down exactly what the graders are looking for, we're going to turn this from a massive hurdle into an absolute breeze. Let's get right into it.
Right off the bat, we need to set the stakes. Look at this quote, literally straight from the College Board's chief reader reports about the data abstraction rubric point. They specifically note that this requirement generates some of the most poorly written responses in all student submissions. I mean, that is a striking fact, but honestly, it's also a huge opportunity for us. By the end of this explainer, you are definitely not going to be in that group. You'll have the exact vocabulary you need to easily secure full credit.
So, here's our survival map for conquering the toughest question on the AP exam. We'll quickly cover the rubric challenge, define abstraction, look at what I like to call the unscalable nightmare, meet our scalability hero, the list, and finish up with a super cool technique, 2 levels of abstraction.
All right, part 1, the rubric challenge. Let's look at exactly what you need to do to win this game. To earn that crucial rubric point, you basically have 2 concrete steps to write out in your response. Step 1 is pretty straightforward, right? Just identify a list in your program and explain what each element represents. But step 2, oh man, step 2 is where most people trip up. You have to explain how the list manages complexity. And to do that, you have to concretely describe what your code would look like without the list and exactly why that version would fail. You can't just wave your hands and say, well, it makes things easier. No way. You actually have to prove it.
Moving on to part 2, defining data abstraction. Before we look at any code, let's make sure we actually understand the core concept here.
What are we even talking about when we say abstraction? Basically, data abstraction is a technique where you group related data values under a single unified name. Think about a list. Instead of keeping track of a bunch of scattered variables, like score 1, score 2, all the way up to score 30, you just deal with one thing called scores. It lets you completely stop tracking individual items, so you can just work with the whole collection as one single entity. One name, one loop, one operation.
Which brings us to part 3, the unscalable nightmare. To appreciate abstraction, we have to imagine coding without it.
I want you to really picture this for a second. Imagine we're building an app. Let's call it the Study Streak Tracker. Its whole job is to store study sessions, so it tracks the date, the subject, and the minutes you studied. What would writing the code for this app look like completely from scratch if lists simply hadn't been invented yet?
Well, it would look a little something like this, and it gets out of hand incredibly fast. You'd have to create a distinct variable for date 1, subject 1, and minutes 1. Then you'd need a whole separate set of variables for session 2. And think about filtering. If you just wanted to print out your math sessions, you'd have to write, if subject 1 equals math, print date 1. If subject 2 equals math, print date 2. It's so repetitive, it's painful.
And you know what? It escalates instantly. Let's say you just want to track 30 study sessions. Your code absolutely explodes. You're suddenly staring at 90 separate variables just to hold the raw data. Can you imagine typing all of that out? Plus, you'd need 30 separate conditional statements just to filter for one single subject. Literally, every time a user adds a new study session, you, the poor programmer, would have to go in and manually write new code?
Now, let's scale this up. What if a student uses your app for an entire semester, say 200 sessions? Your program completely breaks down. It becomes literally impossible to write, impossible to debug, and impossible to maintain. And listen, this is the exact nightmare scenario you need to describe in your AP written response to prove that you understand how a list manages complexity. Okay, take a breath, because part 4 is all about the solution to this chaos. Enter our scalability hero, lists. This comparison right here brilliantly illustrates the difference. On the left, we have our exploding variable nightmare, but on the right, the list. We just create a single empty list called study records. When we want to print out our sessions, we just use a clean, simple for-record and study records loop. You know what the magical part is? That loop body takes the exact same 3 lines of code to print whether you have 3 study records or 300. The amount of data becomes totally irrelevant to the structure of your code.
If you're taking notes, write this slide down. This is the exact vocabulary you want to use on the exam. You explain that abstraction gives you just one variable name to track. It lets you iterate over all your values with a single loop, And crucially, it allows your program to scale to massive data sets without any structural changes to the algorithm. You write one general algorithm, and you let the list do all the heavy lifting.
Finally, let's move to part 5, 2 levels of abstraction. This is a masterclass technique you can use in your Create PT.
Check this out. Look really closely at what we're appending to the study records list here. We aren't just tossing in a single string or a single number. We're actually adding a tuple. See those inner parentheses? We're taking the date, the subject math, and the minutes 45, and clustering them together. The list is holding a grouped package of 3 fields for a single session. This is so brilliant because it gives us 2 completely separate levels of abstraction working together at the same time. Level 1 is the tuple. Instead of 3 separate variables per session, the tuple abstracts the date, subject, and minutes into one neat little unit. Level 2 is the list itself. Instead of 1 tuple per session, the list abstracts all of those units into one big named collection. This 2-layer design means an entire semester of complex data is magically accessible through one single name.
Let's do a quick mental check right now to make sure you see how powerful this really is. With this nested setup, what would study_records bracket 2 bracket 1 evaluate to? Let's trace it together. The first bracket, the 2, accesses the third record in our list, since, we start counting at 0. Let's say that third record is the tuple for September 2nd, math, 60 minutes. The second bracket, the 1, accesses the second field inside that specific tuple, so it evaluates to math. By just chaining those indices, you can effortlessly navigate through an entire semester's worth of data.
All right, I'm going to leave you with this one critical challenge. Don't just nod along to this explainer. Actually think about your own Create PT project right now. In your own words, what does your list manage complexity compared to? I challenge you to sit down right now and write out your own highly specific, unscalable alternative. Imagine your project with 100 inputs and absolutely no lists. What exactly breaks? If you can articulate that nightmare clearly, you aren't just memorizing definitions, you are completely prepared to dominate this rubric point. Thanks so much for joining me for this explainer, and happy coding.